Hello and welcome to 7-4. Today we're going to be talking about similar figures. Now if your brain can go back to last year, we talked about shapes that were congruent, were exactly the same size, exactly the same shapes. And then we have this thing called similar, where they're the same shape but different sizes. Well, they don't have to be different sizes, but they could be different sizes to be called similar. And what we're going to do is we're going to look at how can we use proportions to find the missing measures in our similar figures. So let's get started. Now we are going to start with a little bit of some definitions here. So matching sides of two or more polygons are called corresponding sides. So if they're matching sides, they would be corresponding sides. If they are matching angles, they are called corresponding angles. So we need to know what corresponding sides and angles go with each other. So for example, in this picture shown below, corresponding sides would be 10 and 5. Corresponding sides would be 4 and 2. We can see what our multiplier was. It was times 2. Corresponding sides would be 3 and 6 and 1 and 2. These are all our corresponding sides. Now when we say corresponding angles, we did talk about this a little bit. I showed how if we had two angles, I could say that this one is the same size as this one, and then this one I'd put two lines. We kind of talked about it a tiny bit last year. So anyways, this one has 3 lines, so it'll be a corresponding angle to this one that also has 3 lines. One line, one arc, I guess I should say. So those will be corresponding angles as well. We'll go deeper into this. Let's look at the next definition here. Similar figures. Now this is what we talked about. They have the same shape, not necessarily the same size. Two figures are similar if the measures of the corresponding angles are equal. So when we're talking angles, angles are always going to be equal. A triangle is always going to add up to 180 degrees. If I'm looking at two triangles, the angles will not change. It is the sides that will change, but they will be proportional. So we'll have to do our cross products with our ratios to see if they are proportional or not, or we could use them to find our proportions. Now let's look at a couple problems here. So the two triangles are similar. That's a given. They're not asking if they are similar. They're telling they are similar. But we need to find the missing length and the missing measure of the missing angle. Sorry, the measure of the missing angle. There we go. So I see my missing angle is right here. And my missing length is right here. Okay. So to solve this, I need to set up a proportion. And remember when we're talking proportions, the numerators need to be related and the denominators need to be related. So if I'm looking, we could have flipped the shape too. This isn't going to be exactly easy to figure out here. So here's what I'm looking at. I'm looking at 60, 16, 90 degrees. Here I'm looking at 60, 8, 90 degrees. Okay, so my one proportion I can do, I'll start with the bigger triangle, so I'll put 16 on top, 16 over 8. Okay, now I need to figure out, this will be my x, my missing side. So my relation here is the larger triangle. That's the top, and then the bottom ones would be a smaller triangle. So now I need to figure out, am I going to use the 17 or the 15? Well, I know it's going to be the one that comes right after. Let's see here, I go 60, 16, right angle, blank, 60, 8, right angle, 15. So I know that my denominator would be a 15. I have to find the corresponding sides to figure out what my ratio would be. That's what I'm looking for here. Because I don't want to put, like, let's say, here I'm going to use my hypotenuse. Let's say I used my hypotenuse and I compared it to one of my sides, my legs. Well, that's not going to work because it's not the side that I should be comparing. So I don't want to do that. Okay, so let's get to solving here. If I use cross products, I should do 16 times 5. I mean 15. And 16 times 15 is 240. And that's going to equal 8x. So then I would divide both sides by 8 here. Now I have to figure out what is 240 divided by 8. Well, 8 goes into 24 3 times. So my answer is going to be 30. So x equals 30. Okay, so this missing number down here is 30, which if we looked at our multiplier for all our proportions, 8 to 16 we multiplied by 2, 17 to 34 we multiplied by 2, 15 times what? Times 2 would give us 30. But remember, I know you can solve the easier ones, but we're trying to find strategies for when we get trickier ones. Now we need to figure out the missing side length was 30, and we are missing angle here. Now that's what we need to figure out next. Okay, so we've got a 60, we've got a right. A 60, a right. What angle are we missing? A 30. So if we were to write this out as our answer, our missing length is 30, missing angle is, oh my, look at that. What are the odds? 30 and 30 degrees. So there would be how I would write my answer. So again, to find our corresponding side, our missing side, we would have to set up a proportion. Remember, a proportion is an equation, so it's got an equal sign. We're setting two ratios equal to each other. And then to find our missing angle, we don't really have to do a lot of math. We know that triangles at 180 degrees, so we could use that if we needed to. But generally speaking, we would just have to look at the other one and figure out which angle we're missing. So let's try another one. All right, two triangles are similar. Find the missing length and angle. Okay, so we have to set up our proportion. We could use the hypotenuse. Now the hypotenuse is just the long side that kind of connects our two legs. So if I did the bigger one on top, 40 to 25 equals, now I'm going to do, oh well, I have to do the long side, okay. So it's a big one, so I put X on top here. The long side here. Ooh, this is going to be a little bit trickier, you guys. Okay, so 35, 90 degrees. There we go, 35, 90 degrees. So I should use the 20. Okay, cross products. So when I multiplied 40 by 20, I got 800. Now I need to divide both sides by 25. And then when I did 800 divided by 25, I got X equals 32. So our missing side length is 32. Now there's no easy multiplier to figure that out like the last one. So this one's a little bit trickier. Now to find our missing angles. Now we have the same missing angle on both of our triangles, but we can figure it out because we know that the inner angle or inner degrees of a triangle are going to equal up to 180 degrees. So all I have to do is say my 90 degree angle plus my 35 degree angle, and I would get 125, and then I'd take 180 minus that 125, and I would get 55. So our missing degree is 55. Our missing angle is 55 degrees. So missing side length is 32, missing angle is 55. All right, let's try one more. Children at the ice cream stand was painted by American artist William H. Johnson. This reduction is similar to the actual painting. So when it says similar, it means same size, just different, same shape, just different size. The height of the actual painting is 32 centimeters. So I'm going to do my height as my numerator and my width as my denominator. So the actual painting is 32 centimeters for my height. So this will be my actual, going up and down. 32 centimeters over, we don't know what the width is, but we do know what this the similar painting is. The height is 5 1/10 centimeters, and the width is 6 centimeters. Okay, so now we just do our trusty cross products here. 5 1/10 centimeters equals 32 times 6, which is 192. Now, if we just follow everything the same as we always have, divide both sides by 5 1/10. Okay, 192 divided by 5 1/10. Now remember, when we are dividing decimals, we have to make sure the outside number is a whole number. So really, we're going to be doing 1,920 divided by 51. All right, I'm going to do that, and I would suggest you pause the video right here and do it yourself in your notes. And you know, I almost forgot to read the last part. To the nearest centimeter, that means to the nearest whole number, what is the width of the actual painting? Now, if I was dividing this out, I would have gotten 37 and 6/10. Now, our 6/10 would round our 37 up to a 38. So that's what I'm going to go with. So let's do our width is 38 centimeters for the actual painting. Okay, so again, I just used the ratio that was given to me in the picture. And then I knew that this was the height, so I matched it with the height, the relation for the numerators. And I did my cross products to solve for my missing number. Now, as I'm looking back at this quick, I did see I forgot to put 51x, not 51 centimeters. I needed to have my variable there. So then I would get x equals 38. Anyways, thank you for watching for today. I apologize, it's a little bit of a longer video. But hopefully we'll be able to have a little more background knowledge that will help us out tomorrow for our actual lesson. Anyways, thank you for watching.